Already we seen that mainly there have three kinds of clustering technique, and on one of them already we have learned the k-means clustering technique. Already we have learned this concept in a previous chapter. K-means we will see these things. Now in this chapter we will learn the hierarchical clustering. Hierarchical clustering. HIE. We will see this thing. Hierarchical clustering. Okay. Now let's start. So mainly there have two types of hierarchical clustering. Mainly there have the two types of hierarchical clustering. The first type is the agglomerative types. Agglomerative. Agglomerative type clustering. First one. And it is the most popular one. We will discuss these things step by step. And the second one is the divisive type. Divisive type hierarchical clustering. We will discuss. But the most popular one between these two hierarchical clustering, the most popular one is agglomerative clustering. This is the most popular. Okay. Okay. So now let's see what is this agglomerative clustering. What is this? Now let's try to understand these things step by step. Agglomerative clustering. What is this thing? Let's see. So let's try to understand these things through an example. Suppose let's the data that we have like that, like this kind of data set we have. Suppose let's take these are the data set. These are the data set we. So how much data point we have here? So the data point 1, 2, 3, 4, 5, 6, 7. Here 7. 1, 2, 3, 4, 5, 6, 7. 7, 7, 14. Total 14 data we have. So first thing that we have to taken, we have to consider each point, each individual point as a cluster. First thing that we have to taken. So here we have 14 points. This is one cluster, this is one cluster, this is one cluster. In initial step, we have to take this as a cluster. Okay, so 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Total in initial stage, total we have 14 cluster. So first in first stage, this color. So in initial cell, I'm taking the same color. Just see this blue color first. So in iteration 1, first iterations, we have how much cluster? 14 cluster. 14 points. And corresponding these 14 points, we got 14 clusters. Okay. Now let's see the seconds iteration. In second iteration that we have to do, we have to consider the closest point, a single cluster. So here, just see these things. Here, which are the closest point? Just see this. Here, the closest point is this one. Suppose let's take these two are the closest. These three are the closest. These two are the closest point. And the closest points are take and make a single cluster in the second iteration. Suppose let's take the closest point is this one. These are the closest. These three are the, suppose let's take these three are the closest. Okay, in such cases. So in this stage, in this second iterations, how much cluster we got? 1, 2, 3, 4, 5, 6, 7. In this stage, we got the 7 cluster. Let's take it. But there have some behind it, there have some mathematics. So just try to understand this is agglomerative clustering now, the geometrical point of view. Means this type of calculations we have to make. So first we have to take the edge point as an individual cluster, and in second step we make this cluster to make the cluster to consider the closest point. Simple, by considering the closest point we make this cluster as a single cluster. Just let's take, just in these examples we have taken these 2 points at the closest point and make a single cluster. Similarly here also, here also, here also. So that in second iterations we got it 7 clusters. Okay, now in third step the same things also we have to do. We have to do the same thing as previous step. Just now look after the edge cluster and find the closest one. Okay, now let's take, I'm denoting through this yellow color here. The third iterations, now I am using the yellow color. So suppose let's take these two clusters are now make a single cluster. These 2 clusters are now make a single cluster. This one is a single one. Let's take, and now let's take this one as a single. Now in third iterations, how much cluster we got? 1, 2, 3, 4. Total we got 4 cluster. Okay. So as time progressed, we will make we will the take the clusters. We will take the clusters and find the closest cluster of that clusters and make it as a single cluster. That's the things we have to do. Now let's take at the next stage. Next iteration means fourth iteration. We have to take the next closest cluster. Closest cluster. These 2 are the closest cluster now. This one is a single cluster. Now this one is a single cluster. Okay, now in fourth step we got 2 cluster. 2 cluster. Now at the end we treat these things as a single cluster. Treat these things as a single. Okay. In fifth step we got 1 cluster. These are the steps that we have to. These are the steps. And when we got the single 1 cluster, then we will stop our iterations. Then we will stop our iteration. Now how we will count this? By we will take this cluster as a single cluster by simple using the similarity. Key concept behind it, we will put together the points into a single cluster by using the similarity concept. Means some sense of similarity, we use this concept by simply using the some sense of similarity. By using this concept, some sense of similarity between the cluster. By simple using this, we will make this structure. We will make this structure. Okay, this is the main key idea behind this is the main key idea behind this agglomerative clustering. Agglomerative. This is the main key idea. This is the main key idea behind this cluster. I think you got the one advantage of this clustering is just if you remember the K-means algorithm. If you remember, the K means algorithm. Then we, in that algorithm, in that K means algorithms, we have to choose this K as a hyperparameter. Means according to the value of the K, the clusters have made. Okay, these things are the hyperparameter for the K means. These are the hyperparameters. But here one advantage of this agglomerative clustering is that, see these things here, here have no any hyperparameter. If you want to make two cluster, then just stop here. Don't need to progress the next step. If you want 4 cluster, then stop here. If you want 7 cluster, then stop here. If you want 14 cluster, then stop here. If you want single cluster, then stop here. So every clusters are included in this each step. Okay, this is the main advantage. Here we have not to make some kind of clustering manually. Okay, so these are the automatically inbuilt in this algorithm. So first choose two cluster. Just see these things. So after seeing this picture, if you not sure if this accuracy is not matched on your requirement, then just increase the cluster number. Just increase the cluster. Then suppose let's take you consider it as a 4. And see this. If you satisfied on your accuracy, then stop it. Just doing the same thing. Don't need to compute by using sample by changing the key value. Then the same calculations are don't need to repeat again and again. Okay, just doing this following simple steps, okay, we can easily conclude, we can easily make the clusters. And this is the main advantage of this algorithm. Here the main advantage is, here we don't need to give any cluster. Here we don't need to give a cluster number. Here we don't need to give any cluster number. Means here don't have any hyperparameter. Here don't have any hyperparameter. This is one advantage. Okay, and because of this reason is the most popular one. Okay, I think you will understand how this agglomerative clusterings are work. I think you got the point. Now let's try to understand the divisive divisive clustering. What is this thing? What is this divisive? Now let's see. Divisive clustering. Let's try to see this thing. Divisive. So similarly, we will take the same kind of examples for better understanding. Let's take these are the data points that we have in our data. Similarly, we have taken here 14, but how much point here? 7. Here 1, 2, 3, 4, 5, 6, 1. The total 7 point we have. So first thing that we have to make, we have to treat this whole data set as a single cluster. Just opposite of this cluster. Means in the agglomerative we have take the consider each point as a single cluster, but in divisive we have to consider initially the whole data set as a single cluster. Instead of considering a single data point as a cluster, here we will consider whole data set as a cluster. That's the difference. Here that's just in opposite directions. In divisive we will forward to the opposite directions as we make in the agglomerative clustering. So let's see. So let's take in initial data set this one, we will make these things as a whole cluster, as a single cluster. Okay? Means initially we will consider as a single cluster by with using all the points, with using all the points. Okay, now in this first iterations we will doing this job. Now let's see the third step in the second iteration. Second iterations we will have to divide the point. How will divide? We will divide the point based on the distances. Here we will divide the point based on the sense of some similarity, but here we will divide the whole data set based on some sense of the distance. These are the two clusters. Now the questions arise here. Now the questions that arise here. How to divide? How to divide this data set? Here we will gather the data set by some sense of similarity between the clusters. Here we will divide. Here we will divide some sense of using some sense of distance between two clusters. Okay, means some sense of distance. In agglomerative, we use the similarity concept. In divisive, we will use the distance concept. So in iteration 2, using this distance, some sense of distance. So these distance definitions, these similarity definitions are based on the problem to problem. What is your requirement? Okay, so these are then this kind of distance we have to take as based. These things are based on actually totally our problem. What kind of problem we have? So in second iterations, we will got these two type of clusters. Got these two cluster. Now in third step, similarly the using some concept. Suppose let's take this one is a cluster, this one is a cluster, this one is a cluster, this one is a cluster. Means 4 cluster in this step. Okay, we will see these things, how we will use this similarity concept, what is the mathematics behind it. We'll see these things in the next video. But now in this video, try to understand the geometrical intuitions behind this clustering, hierarchical clustering technique. Okay, by using this same things as doing the same until 14 cluster, until the 14 cluster we will do doing this job. Same thing. Okay, I think you will understand now. I think you will got the point how this hierarchical clustering technique actually works. Now let's try to understand. Now let's try to see what is the dendrogram. What is the dendrogram? Okay, we'll try to understand this dendrogram, how we brought this dendrogram picture to an example. Okay, Now let's try to understand this dendrogram structure, the clustering, through these examples. The examples I am taking from the Google image. Just search it on dendrogram pictures, then you will got this kind of picture. Okay. Now let's try to understand. Suppose let's take, these are the data sets that we have. These are the data set. Means 1, 2, 1, 2, 3, 4, 5, 6. These 6 points. Suppose don't be confused. Just remove. Now suppose now just omit this point. What is this? Now just remove this point for a while. Just remove this point. Okay. Just remove this point for a while. We will discuss everything step by step. Suppose let's take, these are the 4 points that we have. These are the 6 point that we have. 1, 2, 3, 4, 5, 6. Now in 5, 6, if you just remember, the agglomerative clustering, in agglomerative clustering, initially we treat each cluster is a single cluster. So initially we will treat these things as a single cluster. This one, this one, this one, this one, this one. Each is a single cluster. So this is the initial stage. Initial stages we have 6 cluster. Okay, initial stages we have 6 cluster. Now in the second stage, in the second iterations, we will close together, we will merge the closer point in together. So in the second iterations, I am using this color pink ink for the second iterations, for the iteration 2. For the iteration 2, we will use this pink ink for iteration 2. Now this is the one cluster. This is the cluster. I am using the C1 for cluster 1. Cluster 1, this is the cluster 2, 4 is the cluster 3, and 6 is the cluster 4, C4. Okay, so in iteration 2, just see these things. We will make, this is a cluster 1, we will merge C1, 1 and 3. This is the cluster 1, 2 and 5. This is the cluster 2, 4 is the cluster 3 simply, and 6 is the cluster 4. We will doing this thing in iteration 2. Now let's see the iteration 4. Iteration 4. Sorry, iteration 3. Let's see this iteration 3 step. So iteration 3, in iteration 3, now in iteration 1 we make this one a single cluster, single cluster, single cluster. Now iteration 3 we will take the closest cluster. Now see these things. The iteration 3, the closest clusters is which one? The closest cluster are these two one. C2 and C3 are the closest cluster. C2 and C3. So C2 or C3 is now a single cluster. It is as a C5. After iteration 3, we see that this is a cluster C5. This is a cluster means C1, and this is a cluster means means C4. Okay. After iteration 4, iteration 4. In iteration 4, we will get together on the closest cluster. We will merge the closest cluster. What is the closest cluster here? C1 and C5, the closest cluster now. So we will merge it. C1 and C5. We'll merge it and call it as a single cluster. So let's call is a single cluster C1 and C5, and let's call this a 6, 6. C6 and C4. We have C6 and C4. Okay, and at the end iterations, at the final stage, final iteration, iteration 5, we will merge the C6 and C4 into a whole big cluster. All this cluster is C7. Since I'm doing this mistake here. This is now the C4. That it's my bad. C4. Now I will mark C4 and C6 and make a single cluster C7. This is the now C7. This is the C7. Okay, that's the job. That's the job of we have to make. So just see these things. These pictures are actually, if you closely see these things, these pictures are actually tree type picture, tree like picture. These are the tree like picture. And this one decision tree chapter, and we will see these things in random forest chapter. We will see various kind of trees. So this is like a tree type structure. So these tree type structures are actually called a dendrogram. Dendrogram. These are the call actually a dendrogram. This is a dendrogram. Okay, I think you will understand what is this actually. Dendrogram. These pictures are called the dendrogram. Okay, I think you got the point from these examples from this discussion. Dendrogram is, if you write these definitions of the dendrogram is a tree-like diagram. It is a tree-like diagram okay, that records the sequences of march or split. March or split. So it is a simple tree-like diagram or tree-like structure that records the sequence of march or split of our data. Okay, and we will see already. We will doing the march only for agglomerative clustering, only for agglomerative clustering, and we splitting the data for divisive clustering. Okay, we will march the data set when will we make the agglomerative agglomerative clustering, and we'll split the data set. We use the divisive clustering. Okay, I think you from this lecture you got the idea behind the hierarchical clustering, how these things are actually work, what is its geometry intuitions, I think, and what is its advantage from the k-means. Okay, in k-means we have the hyperparameter concept, but here there have no need to take any hyperparameter. That's the first advantage. Second advantage is, as our requirement, we can choose our cluster number of cluster. That's the second advantage. Third advantage is, here we can easily draw a tree-like diagram. We call the dendrogram. Okay, this kind of, because of these three kind of advantages, mainly this kind of advantages, this hierarchical clustering is the most popular clustering technique among all the clusters. Okay, and in the next chapter we will see the density based clustering. Then also you will see there have some also advantage from the hierarchical clustering, but hierarchical clustering is also itself a more popular clustering. We'll see these things. We will see its mathematics behind it in next chapter.